Conservation of energy and energy degradation. Law of conservation of energy. In our earlier session, we have learnt about different forms of energy. Now, let us learn about conservation of energy. We have already learnt that energy occurs in different forms, like kinetic energy, potential energy, light energy, heat energy, etc. Generally, the energy transfers between objects. For example, if you hit ball on the ground, energy has transferred from you to the ball and the ball started moving. The car engine burns the fuel in the car. Thus, fuel transforms from chemical energy to mechanical energy and car starts moving. According to law of conservation of energy, the energy is neither created nor destroyed, but it transforms from one form to another form. However, the total energy remains constant. Application of the law of conservation of energy to a simple pendulum. In our earlier session, we have learnt about law of conservation of energy. Now, let us learn how law of conservation of energy is applied. Let us explain it by using a simple pendulum. Activity. Let's take a simple pendulum and suspend it from a stand. The normal position of the simple pendulum is noted as OA. Now, pull the bob of the pendulum at one extreme position B and release it. It reaches to the other extreme position C and goes on. If the bob goes from B to C and come back to B and so on, it is called as one oscillation. When the bob is at extreme positions B and C, its velocity of the bob is zero, so its kinetic energy, Ke, is zero. When the bob is above normal height, h, that is, when it is at extreme points, it has potential energy, Pe, so its Ke is zero. But when the bob leaves the extreme position and crosses its mean position, its height h is zero. Then its Pe is also zero and has kinetic energy. At equilibrium position, it has kinetic energy and potential energy is zero. And at extreme position, it has potential energy and kinetic energy is zero. In between equilibrium and extreme position, it has both potential and kinetic energy. Other than the equilibrium and extreme positions, any point in the oscillation has total energy sum of Pe and Ke. The sum of Pe and Ke always remains constant. Thus, from the above experiment, we can find the energy is transformed from potential energy to kinetic energy and from kinetic energy to potential energy. But it is neither created nor destroyed. This is called as law of conservation of energy.